Okay, this time I'm going to go through this quite quickly because I'm not sure the camera is working properly, but I'm going to do it anyway. Okay, so hopefully you can read it. This is a test I recently did with my students on waves and sound, GCSE questions, and the four questions I've got listed as to what we go through. So wave properties on two of them, hearing range, V equals F lambda, and echolocation using pulses of sound to work out distances. Okay, the first question is multiple choice taken from IGCSE EdXL. The first one wants you to identify the amplitude. So the amplitude is the height from the center of the wave, because that's where it's 0 to the maximum. Because remember, the displacement is when the wave is disrupting the medium. When you stop disrupting it, it will go back to the equilibrium position, which is the center. So S is the answer. Which arrow represents the wavelength of the wave? The wavelength is from peak to peak, or any two corresponding points on consecutive waves. So the answer for B is Q. The answer for question B is Q, which is the answer. Third question, what type of wave is a water wave? The water waves are transverse, longitudinal. Sound waves are longitudinal. Most other waves you'll meet are transverse, like water waves, light waves, electromagnetic waves. The next question wants you to use the equation F equals 1 over T. They've given you the T. They want you to put it into the equation. It's 1 over T. Yeah, 1 over T gives you 0.37. Units being given to you, so you're not getting it for the units. You just need to make sure you've got the answer. And 2 decimal places would be correct because you've got 2 significant figures of the data. Okay. Second question is about energy transfer of a wave going this way. You can see how many waves there are. A rope is being moved up and down. So there's waves on a rope. You can see there's 1, 2, 3, 4 waves, and it says there's 2 seconds across when you read the data. Okay, so what type of wave is traveling? Again, it's transverse because the vibrations are oscillating at right angles to the direction of wave travel or direction of energy transfer. They want you to know that. 1 mark for saying it's transverse. The next part of the question says how many, the waves shown in the diagram were produced in 2 seconds. How many waves can you count? The answer is 4. So 4 waves in 2 seconds, that's 2 waves per second, which is 2 hertz. Calculate the time period. If you know the frequency, you know the time period is 1 over F, as we did in the previous question. So it's 1 over 2, which is always, you use decimals in physics. So you put the time period, that's seconds. The unit of hertz is for frequency. So it's 0.5 seconds, the time of 1 wave. So 2 waves in 1 second. Okay, question 3 is about the frequency range of different animals. Bats from 20 to 160,000 hertz, dolphins from 40 to 110,000 hertz, elephants from 5 to 110,000, and humans from 20 to 20,000. I've added that in because that's what I've taught my students. They then converted that into the wavelength range. Remember, because if V equals frequency times wavelength, which is the wave equation, if the frequency goes up, the wavelength goes down. So this maximum frequency will correspond to the minimum wavelength. This minimum frequency will correspond to the maximum wavelength. So if you multiply the maximum frequency by the minimum wavelength, you'll get the speed of sound. So that's what they want you to do later on. It says which animals can hear sounds higher than humans. Well, that's bats and dolphins, so that's 1 mark. Which ones can hear lower frequencies? By lower, they mean frequency, and that's elephants. They now want you to do what I've showed you. So if you multiply these values together, you should be able to work out the speed of sound if you do it correctly. The speed of sound should be the same for whichever animal you're doing it. But since we're focusing on the elephant, calculate the minimum wavelength. That's X in the table above. That they can hear. Note wave speed is constant, so you can work it out? Well, wave speed is the minimum frequency to the maximum wavelength. So if I put 5 from the table times as the minimum frequency times the maximum wavelength for the elephant was 68.6, gives you 343 meters per second. Once you know the wave speed is 343 meters per second, you can then work out the minimum wavelength, okay? Because 343, which is the speed, is going to be equal to 10,000 times the minimum wavelength, lambda min. Okay, that means lambda min is 343 divided by 10,000. Oh dear. Lambda min will be equal to the speed is 10,000, the frequency at the top of the range for the elephant in the table above, times the minimum wavelength. So if you change the subject formula, divide 343 by 10,000, it will be 343 divided by 10,000. So that's going to be decimalized point. So that means you go about 12345.0343, I think, meters, if I've done it correctly. None of my students got that right, but some of them did work out that you had to work out the speed to be able to determine the minimum wavelength. Okay. Finally, question 4 is about a submarine sending pulses of sound down to the seafloor and timing how long they take to come back. Well, so if they're timed to go back, the pulse returns in 0.35 seconds after leaving the submarine. How far did it travel? Well, the thing is, how far did it travel? The minimum speed of sound in air is speed of sound in water is 1600 meters per second. So that's the velocity. Calculate distance. Remember, it's going to go there and back. So the sound's going to go there and come back. So it's traveled twice the distance. So it's 2x over t is the velocity. We know the velocity is 1600. We know the pulse rate is 0.3. So 2x is 560 meters. That means the distance to the floor bed is 280 meters. That's how you get the 2 marks. Okay? The last part of the question is referring to the fact that the submarine keeps sending sounds out. Oh, my focus has come back. That's good. The submarine keeps sending the sounds back. And here you see it took 0.5 seconds, then it goes down. The third pulse takes 0.38 seconds. That means it's closer. And then 0.25 seconds means half the depth. So pulse 1 and 2, yeah, is a bigger distance. Yeah, because the pulse rates are 0.5 seconds. The next two, pulse 4 and 5, are double the distance, half the distance. Half distance. Because it's 0.25 seconds. Yeah, pulse timings. So they're going obviously half the distance, and pulse 3 is in between. So it's about halfway in between, so it's a medium distance. Now, as long as you say something about the different pulse numbers, so they want you to change over these 5 pulses, so you need to somehow get all of them in, and the mark scheme will be more specific than this, but so the medium distance will be pulse 3. So you can see they're going from deeper water gradually into shallower water. So what can you describe how distance changed over these 5 pulses? The distance became smaller. Yeah, so the conclusion is distance got smaller. From pulse 1 to pulse 5. Yeah? So they want you to refer to over the 5 pulses. Okay, so that's basically the 4 questions I gave my students last week. You can use this to go through the errors. I'm going to show you those questions again, so you can stop the video now. The focus is back. I don't know what went wrong with my camera. Here's the first page, so you can now have a look at it in more detail. Okay, so there's question 1. First one is D, then B, then D. Stop the video when you want to go through it. There's the reverse, how to work out the frequency. Question 2, 4 waves going in 2 seconds. The transverse wave, because the rope is vibrating up and down as the direction of the energy transfers or the wave travel is to the right. That's frequency of 2 Hertz because there's 4 waves in 2 seconds. That's 2 waves a second. If you know the frequency, you put 1 over the frequency and you get 1 over 2. You decimalize it, always in physics, and don't forget the units for the second mark. Okay, 1 for doing that, 1 for the unit. Okay, and then question 3, well, you can see the numbers now. So remember, 10,000x, you could say 10,000 times x, the value, the maximum frequency times the minimum wavelength must be equal to the other two numbers, 5 times 68.6. So this is another way of doing it. Yeah, at the end you can then work out what x is. Okay. Bats and dolphins, first question, can hear higher sounds, and elephants can hear lower sounds. And there's another way of doing it: work out the speed, and then work out the unknown value, which was x. Yeah, so x is the minimum wavelength, and the focus is gone again. Yeah, so it looks like there's a problem with the camera. Hopefully it will fix itself, because it's very annoying. Okay, so I can't show any more clearly than that. There's the end of the paper, which we went through before. Hopefully you can see it. Okay. All right, well, that's it for now. So I'm going to share the video if you found it useful, and share it with your friends so they can have a look at it. So my students, I expect you to use the video to see which ones you got wrong and then improve it. This is a question I gave in another class, which I'm not going to go through now because I was going to show with a clear focus on the camera, but it looks like the camera is playing up. Yeah, so it looks like there must be a loose connection somewhere in the camera which is not wanting to focus. Okay, well, for anyone who wants to have more GCSE questions like this answered on the video, hopefully once the focus is correct, please subscribe to our channel. We now have over 160 subscribers, and we started this service in January. Thank you very much for watching. See you in the next video. Bye for now.